Hello everyone, this is Sublakshmi. I am here to explain the root finding numerical methods to find roots of a given equation. The root finding technique involves certain methods to find the roots of an polynomial equations as shown here. The number of roots of an equation is given by the degree of that curve. If it is a cubic equation, then the number of roots for this curve will be 3. The roots are obtained at the points where the curve cuts the x-axis. Or in other words, we can say that a value of x that satisfies this equation and yields the value of y as 0 is called the root of the curve. For this dummy curve that cuts x-axis at point say m, therefore m satisfies this equation and thus it is one of the roots of this curve, similar in the case of other 2 points. There are a number of iterative methods that will find the root of given curve within an interval. The first is the bisection method. The preliminary requirement for a bisection method is an interval in which the root has to be found. Say this interval is a, b. As the method's name suggests, this interval is bisected and a new point m is calculated and the analysis for root is made at this point m. If the functional value of m, that is f of m, becomes 0, then m is the required root. This becomes more clear with this graph. A given interval a and b. We are bisecting this interval and getting a point m. And we are analyzing the root at this point. If the functional value of this point doesn't become 0, it means the curve is not cutting the x-axis at point m. Then again, now the interval is changed from a to m. And again this interval is bisected and checked whether the root is obtained at the new point. Until the root is obtained, this iteration goes on. Let us have a look at the flowchart of bisection method. Here we are reading two numbers, that is the initial interval from the user, and we are checking whether the interval is so that it occurs at the either side of the root, that is a and b falls at two different locations and the root is in the mid. If it doesn't happen so, then the root cannot be found. If it happens so, then this interval is bisected and a point m is calculated. And this m is checked whether this is the required root. If it is not so, then a new interval is obtained by some logical comparisons. Say f of a into f of m is greater than 0. If it happens so, then a becomes m, and if it doesn't happen so, then b becomes m. Then a new interval is obtained. Again this interval is bisected and it is checked for the root. This iteration goes on until root is obtained. If f of m becomes 0, then this is the required root and the root will be print. Let us have the programmatical analysis for bisection method. Here we are finding root for an equation x cube minus 4x minus 9. Here is a function that will return the value of this function at a given point. At first, we are reading the interval values from the user, and as it was shown in the flowchart, this interval is bisected and checked for the root. If root is not available, then this while loop goes on until the root is caught. Here we are comparing the functional value of m with 0.0001, because in floating point numbers it does not happen that any value is absolutely equal to 0. So we are taking an approximation of 0.0001. In this while loop, a new interval is obtained by such logical comparisons, and again a new value of m is obtained. So let us run this program. I am giving the first value as 2 and the endpoint of interval as 3. The root is 2.70652 and the iteration number is 15. It means the root is lying between the point 2 and 3. If I change the interval, say I am taking 4 and 5 as the interval, then it shows that no root exists in this interval. That is, between 4 and 5 there is no available root. This was all about the bisection method. Thanks for watching.